So we'll continue with the problems from Fourier Transform. This is also a standard question. Find the Fourier transform of f of x equals e power minus a square x square, where a is a real constant. Start with the definition. F of x or f of alpha is defined as 1 by root of 2 pi integral x equals minus infinity to plus infinity f of x e power I alpha x dx. So what is f of x here? E power minus a square x square. So 1 by root of 2 pi integral x equals minus infinity to plus infinity e power minus a square x square e power I alpha x dx. So f of x is e power minus a square x square, that is substituted here. Then the next step, the exponential terms are multiplied, so the powers are added. So in the power, the minus is taken out, so e power minus of a square x square minus I alpha x dx. Take this expression as 1. Now the next step, consider this one, a is a square x square minus I alpha x. I can write this as ax the whole square minus I alpha x. I want to express this as a minus b whole square. I want to express this as a minus b whole square. So the given expression is of the form a square minus 2ab. So b square is missing. So we have to add and subtract b square. I repeat, the given expression is of the form a square minus 2ab. We have to add and subtract b square to get a minus b whole square. So we should find b. So compare these two terms. 2ab equals I alpha, because x is in the first term. 2ab equals I alpha. So what is b? I alpha by 2a. So this b square is added and subtracted to this term. I repeat, we have multiplied the exponential term, the powers are added, minus is taken out, and then we are expressing the bracket term as a minus b whole square. So to express it as a minus b whole square, the expression a square x square minus I alpha x is of the form a square minus 2ab. So we have to find b, that is we have to add and subtract b square. So to find b, you compare these two terms. 2ab equals I alpha. I am not taking x because x is in the this term, the first term. So 2ab equals I alpha, b equals I alpha by 2a. So in the next step, ax whole square minus I alpha x, b square minus b square. So what is b square? I alpha by 2a whole square minus I alpha by 2a whole square. So b square is added and subtracted. So the first three terms is of the form a square minus 2ab plus b square, or a minus b whole square. So what is a? Ax. What is b? I alpha by 2a. So a minus b whole square minus the last term, I square alpha square by 4a square. I repeat, the first three terms are of the form a minus b whole square. What is a? Ax. What is b? I alpha by 2a. So ax minus I alpha by 2a the whole square minus the last term, that is I square alpha square by 4a square. You know that I square is minus 1. So minus of minus plus alpha square by 4a square. So now I can write a square x square minus I alpha x as ax minus I alpha by 2a the whole square plus alpha square by 4a square. So this is written here. We have taken this as 2. Now 2 is substituted in 1. So what is 1? E power minus a square x square minus I alpha x. So this power a square x square minus I alpha x is taken as this expression. So we have used 2 in 1. So a Fourier transform of left side, Fourier transform of e power minus a square x square equals 1 by root of 2 pi integral minus infinity to plus infinity e power minus of this term, that is ax minus I alpha by 2a the whole square plus alpha by 2a the whole square. Then it is split into 2, e power minus ax minus I alpha by 2a the whole square into e power minus of alpha square by 4a square. This expression is split into two exponential. This exponential term is split into two exponential, that is e power minus of ax minus I alpha by 2a the whole square into e power minus alpha square by 4a square. Now e power minus alpha square by 4a square is a constant, so that is taken outside. So 1 by root of 2 pi e power minus alpha square by 4a square integral minus infinity to plus infinity e power minus of ax minus I alpha by 2a the whole square into dx. So this term is taken outside, and the next substitution is this is taken as t. So t equals ax minus I alpha by 2a dt equals a dx. As x varies from minus infinity to plus infinity, t also varies from minus infinity to plus infinity. So this integral is rewritten in terms of t. So 1 by root of 2 pi e power minus alpha square by 4a square integral t equals minus infinity to plus infinity e power minus t square, and what is dx? 1 by a dt. So this is t, this we have taken it as t, so e power minus t square, and dx is 1 by a dt. Then the next step, 1 by a is a constant, so it is taken outside. So 1 by a, 1 by root of 2 pi e power minus alpha square by 4a square integral t equals minus infinity to plus infinity e power minus t square dt. Now this is t square is an even function. Whenever you have this form, integral minus a to a f of x dx form, you can use a property of definite integrals. Whenever you have integral minus a to a f of x dx form, you can use a property of definite integrals. So the result is 0 when f of x is odd, and 2 times integral 0 to a f of x dx when f of x is even. So we have seen this in Fourier series. So t square is an even function, so you can write it as 2 times integral 0 to infinity e power minus t square dt. So in place of minus a to a, you have minus infinity to plus infinity. In place of f of x, you have e power minus t square. So it is written as 2 times integral 0 to infinity e power minus t square dt. And this integral is same as the value of this integral 0 to infinity e power minus t square dt is same as root of pi by 2. So that is substituted here. So 1 by a, 1 by root of 2 pi e power minus alpha square by 4a square 2 times root of pi by 2. So 2 gets cancelled. You have 1 by root 2 into 1 by a, and root pi also gets cancelled. So 1 by root 2, 1 by a e power minus alpha square by 4a square. So you have to by heart this result. It's a very important problem. If you practice 2-3 times, you will get the standard question. So the first substitution, first you have to get a minus b whole square, then you should take this as t, then we are using the property of definite integrals, then here we are using the concept of gamma function. You have learned this in gamma function. This integral is same as root pi by 2, that is substituted here. So you should remember all these substitutions to get the Fourier transform. So with practice you will be able to do well. So remember, Fourier transform of e power minus a square x square is 1 by root 2 1 by a e power minus alpha square by 4a square. Now from this we have to deduce these three expressions. So first one, e power minus x square by 2. So you have to get this from 1. So in place of a square you have half. You compare these two. A square is half. So if a square is half, a is 1 by root 2. We always take the positive root. If a square is half, you compare these two. E power minus a square x square with e power minus x square by 2. So a square is half, a is 1 by root 2. So substitute a as 1 by root 2. So 1 by root 2 into 1 by root 2 e power minus alpha square by 4 into half. A square is half. So root 2 gets cancelled, you will get e power minus alpha square by 2. So this is the answer for the first part. Now for the second part, e power minus x square. Now you compare e power minus x square with e power minus a square x square. A square is 1. So a square is 1. So you compare these two, e power minus x square with e power minus a square x square. A square is 1. If a square is 1, a is 1. So 1 by root 2, a is 1, e power minus alpha square by 4 into 1. A is 1, a square is also 1. So you will get 1 by root 2, e power minus alpha square by 4. And the last one, e power minus a x square. You compare these two, e power minus a square x square with e power minus a x square. In place of a square you have a. In place of a square you have a. So replace a by a square. So replace a square by a. You see, in place of a square x square you have ax square. So replace a square by a. So here it will be, if you replace a square by a, it is a will become root a. If you replace a square by a, this is a minus alpha square by 4a. So if it is a square you have a. If it is alpha square by 4a square you have a. If it is alpha square by 4a, then the corresponding a will be root a. So 1 by root 2, 1 by root a, e power minus alpha square by 4a. I repeat, to get e power minus ax square, replace a square by a. So this a square is replaced by a. So if it is a here, it will be square root of this a, that is root a. See, you see here, if it is a square, you have a. If it is a square, it is a. What is a? So square root of a square. So what is square root of a? It is root a. So 1 by root 2, 1 by root a, e power minus alpha square by 4a. So learn this problem. It is very, very important. Now we have a definition, self-reciprocal. See, if the Fourier transform of a given function is same as the given function, if a Fourier transform of a given function is same as the given function, we say that they are self-reciprocal. Say for example 1. If you take 1, what is the reciprocal of 1? 1 itself. So we say that 1 is self-reciprocal. Same way, if you take the Fourier transform of e power minus x square by 2, we have seen that here. What is Fourier transform of e power minus x square by 2? E power minus alpha square by 2. What is the transform of e power minus x square by 2? E power minus alpha square by 2. So you are getting back the same function. The function is same, only the variable is different. E power minus x square by 2, e power minus alpha square by 2. In place of x you have alpha. So these are self-reciprocal. F of x is self-reciprocal with respect to the Fourier transform. If the Fourier transform of a function is same as the given function, we say that they are self-reciprocal. So they can ask you, show that f of x is self-reciprocal. So for that you have to write, for this this one you have to write the proof of this question plus deduction part. You have to start from this. They will ask for 7 marks. You have to write this, and then you should replace a square by half. You have to write from the beginning up to this term, up to deduction part A. You have to write the proof of this and then replace a square by half. Now next one, starting with the Fourier transform of e power minus ax square, find the Fourier transform of g of x equals x e power minus ax square. So what is given? F of x equals e power minus ax square. So how can you get x e power minus ax square from this term? How can you get x e power minus ax square from e power minus ax square? So if you differentiate x square, you will get 2x. So you have to use transform of derivative. I repeat, how can you get x e power minus ax square? If you differentiate x square, the derivative of x square is 2x. So from that you will get x e power minus ax square. So we have to use transform of derivative property. What is that property? If f of x tends to 0 as x tends to plus or minus infinity, then the transform of f dash of x is minus I alpha into transform of f of x. What is the transform of derivative? The transform of f dash of x is minus I alpha times the transform of f of x. So what is f of x? It is given to be e power minus ax square. What is f dash of x? E power minus ax square into minus a into derivative of x square, that is minus 2ax into e power minus ax square. What is the derivative of x square? 2x. So 2x into minus a into e power minus ax square. But 2a is a constant. So minus 2a into x e power minus ax square. Now substitute this in 1. You know f of x, you know f dash of x. So what is f dash of x? Minus 2a x e power minus ax square minus I alpha. What is f of x? E power minus ax square. So in 1, the f of x and f dash of x are substituted. What is f dash of x? Minus 2a x e power minus ax square. What is f of x? E power minus ax square. Then minus will get cancelled. You have minus on both sides. 2a you can take it out because it is a constant. So 2a I have taken to the right side. So I alpha by 2a Fourier transform of e power minus ax square. So what is Fourier transform of e power minus ax square? We have seen that here 1 by root 2 root a e power minus alpha square by 4a. I told you you have to by heart this. So 1 by root 2 into 1 by root a e power minus alpha square by 4a. So that is substituted here. So I alpha by 2 root 2 a root a e power minus alpha square by 4a. I repeat, you should by heart you should remember the transform of e power minus a square x square. You will be using in problems. E power minus ax square, e power minus a square x square, e power minus x square by 2, e power minus x square, e power minus ax square. All the 4 are very important. If you remember at least the first one, you can do the rest. So remember this expression by heart, this one. I will give it as in the formula page later.